Alrighty, good afternoon, everybody. Welcome. Thank you for taking the time to join us here at Virtual Fourth Space for today's event, Microbes and Cell Agriculture for Sustainable Food Production. There will be a follow-up event to today's interactive panel discussion on September 3rd, so do follow iGEM and FourSpace for details to be released soon on that. But for now, we welcome iGEM event organizers and participants, special guest speakers and industry leaders, and you, the audience. Thanks for your participation. This 1-hour webinar will be followed up with a networking session that you're all invited to. So this will give you an opportunity to engage further with today's panelists and participate in breakout sessions for further opportunities to learn and discuss, question. I will paste the invitation to this post-webinar event in the chat as soon as I'm finished speaking, and I'll do so again at the end as well, at the end of the webinar. For now, we hope you enjoy the presentations that will be moderated by synthetic biology PhD candidate Kanza Simlali. If you have questions throughout the session, we invite you to paste those into the Q&A that you see at the bottom of your screen, and Kanza will attend to them in due course. If you're watching on Facebook, hi, please feel free to comment and we'll ensure that panelists receive your questions here as well. It's my pleasure now to pass the mic over to Kanza. Welcome, Kanza.
Hi, Anna. Thank you so much for the introduction. So today we have a couple of really great speakers. First, yes, I'll continue Anna's spiel on the couple of practical things. So please post questions in the Q&A. I will try to answer them. We will start with the introductions of the two iGEM teams who are presenting this webinar, and then we will have 3 presentations of our 3 lovely speakers. And I'll pull up some slides now so we can look at their introductions. So today we'll be listening to a presentation from Michael Selden from Pinless Food. Secondly, Michelle Iser. And third, we have Ahmed from Cell Agri. I'll be introducing them later. First, we will listen to our 2 iGEM teams who are presenting a little bit about themselves now. So go ahead, iGEM Laval.
Hello, everybody. My name is Ángel Cisneros. I am a team member at iGEM Laval. I'll leave Emily to introduce herself.
Hi, I'm Emily Alexander, also part of iGEM Laval. This is my first year participating. I'm also going to give a quick shout out to Ben, who can only be listening today, but he also helped us planning this event. So that's the introduction.
So briefly speaking, iGEM is an international competition on synthetic biology. Teams from around the world work on a project throughout a year and get to present it at the end of the year in November. Our story is that we at Team iGEM Laval, we were interested in working in the maple syrup industry. And so we were looking for different problems in the maple syrup industry that could affect production and especially affect small producers. And we found this specific problem that's called ropey maple syrup. It's a class of maple syrup that is too viscous, and so it is completely undesirable. It is actually thrown away. So imagine like investing energy and resources on a product that we will have to throw away in the end and even like pay extra to destroy. So this is very bad for small producers. We looked at different potential solutions that we could use to address this problem. And so we've been through a lot of discussions with different experts, seeing which solutions are viable and which are not. And in the end, we settled on designing a biological treatment at the end stage of this, directly on this product, to try to make it, to turn it into something that resembles maple syrup, which could not necessarily be used as directly maple syrup, but it could be used to design many other products, like say vinegar or even alcoholic drinks. In particular, we would like to use an enzymatic treatment. We will be very happy to tell you more about this in the discussion at the end of the session. And we're very happy to be here organizing this SciComm event with iGEM Team iGEM Concordia.
Right, iGEM Concordia, would you want to introduce yourself?
Hi, so I'm Lancia from iGEM Concordia, here with Paula and Hajar as well. Our project, we were inspired by the announcement of the 2024 SpaceX crewed flight to Mars, and our team asked, how do we sustainably fulfill the nutritional needs of a crew of astronauts on an 80 million mile, 3-year mission to Mars? So currently NASA sends up food in dehydrated packets. Astronauts are reliant on a food supply chain from Earth. This is resource consuming and not sustainable, especially for long-term crewed flights. Nutrients also degrade over time. So currently, synthetic biology offers sustainable solutions to food security here on Earth. Cells are cultured like mini factories to produce a range of products, which you'll hear about today, from nutrients to biomaterials and microbes, and for iGEM Concordia, our favorite baker's yeast. With these mini factories, astronauts could carry a small vial, milliliters of vitamin A, let's say, producing yeast cells, and then culture the cells as needed to produce more nutrients, reducing the reliance on the supply chain to Earth. So what's the challenge? In space, microgravity conditions, which is why astronauts float, results in poorly understood genetic changes in the cells. We see movement of the cytoskeleton to changes in protein production, which would be our vitamin A production, for example. This translates to unpredictability for bioproduction in space. So our project, our solution is Astro Yeast. We are designing space-compatible yeast strains to alleviate the stress responses seen in yeast due to microgravity conditions. Our Astro Yeast are tailored and tolerant for microgravity and can be used as reproducible, renewable mini factories in space to produce nutrients for sustainable space exploration or habitation. We are excited to be collaborating with iGEM Toulouse and iGEM Calgary for vitamin A production in space as our proof of concept. Very excited to be here today with you, Laval, and all of our speakers. Back to you, Kenza.
Thank you. So now we will give the word to our first speaker. All of our speakers will do a 5-minute presentation, after which a quick poll will pop up for you all. And then we'll also take questions from the audience. So if you have questions that pop up during their talks, please put them in the Q&A. So Michael Selden, he's the CEO and co-founder of Finless Foods. And Finless Foods, I'll quickly read your bio here, is the only company currently capable of growing cell-based bluefin tuna. And they do this with the mission to help the ocean thrive by revolutionizing the seafood industry. So Michael, I will let you share your screen now.
Love it. Thanks so much. And thanks everybody for having me. I really appreciate the opportunity. Let me just get my slides up. Is that working out? Cool, I'm seeing some heads nodding. Anyway, so yeah, like I was introduced, my name is Michael. I'm co-founder and CEO of a company called Finless Foods. We're the world's first cell-based seafood company. We started back in 2017. So yeah, let me start with this. This is two types of fish that are both, I would say, extremely good. One is called hamo and one is called kampachi. But neither are very popular worldwide, despite the fact that, like, when eaten, no matter where, people really seem to love them. And so I'd just like to dive into why people don't eat this thing, if it's pretty good. And I would say that that's a factor not, not of what they are, but of how they are produced, how seafood in general is produced. So let's talk about like how seafood is produced. Generally, when people talk about seafood production today, they're talking about boats. You got people on the water pulling fish either out of wild stocks or out of fish farms, which are generally offshore. And then you have those people like, selling those on shore. But, I'm a biochemist. And so when I think about how fish is produced, I think about it on a cellular level. You have satellite cells that reside in muscle in fish, dividing to create more of themselves. These cells then, differentiate into different functional lineages and sort of twist together. You've got like fat cells, muscle cells, connective tissue. They twist together to form muscle fibers. And this is the building block of meat. And so if we see this as how fish is produced, rather than thinking about abstract things like boats, I think that we can start solving this, what I see as a supply chain problem. So at Finless, that's what we do. We make the healthy fish that we feel you deserve. Yes, even you. And basically, this is what we do at a more detailed level. We take a sample from a real live fish of animal cells. We pull those cells out, just isolate the strongest, healthiest, tastiest ones, and give them the nutrients and environment that they need in order to grow into large amounts of fish meat. And this is not like a veggie burger. It's not vegan. It's not the Impossible Burger. It is on a cellular level the same thing that people eat today. It's just instead of growing it between the bones and skin of a fish, we grow it outside of an animal. And so there's a lot of advantages to this process. But basically, like, you know, everything from the obvious stuff, like we have no mercury, we have no plastic, we don't have to engage in animal cruelty, we don't have to destroy ocean stocks. But I think if you're watching this talk, you probably know a lot of that stuff. So I'd like to just dive into some more detailed stuff. We can make fish faster than it's currently made. Here's a comparison of some basic animal cell bioreactors. These are in a factory in Korea, and comparing them to the most efficient fish farming that exists today, which is salmon mariculture. In terms of just raw tonnage, you're actually putting out considerably more fish with a considerably smaller footprint, closer to where consumer demand is for faster and cheaper than what's being produced right now in these fish farms. And there's a lot of other advantages. Right now, when fish is made, or produced rather, it's pulled out of the water on these boats and then sold to people at docks, who then sell to national distributors, sell to local distributors, sell to grocery stores and restaurants, then eventually to consumers. This creates a lot of middlemen, and it creates a product that's considerably less fresh. It's getting knocked around in transit, so there's physical stress on it, which reduces its quality. We can make something that is local. We can produce any variety of seafood in any geography, crunching that supply chain down, making it more affordable for everybody, increasing its freshness, increasing its quality, and decreasing all the carbon emissions associated with shuffling food around the planet to get it to different people. And you know, using this technology, we can even produce things like kampachi and hamo absolutely anywhere. Right now, neither of these species are farmable, and so both their wild stock are located in like one very specific geography, are fish cleaned every single year. So it's a supply problem. There's only a limited amount of these two types of fish. It's only in one specific area, and so it's only eaten by people in that one specific area. What we can do is make this local, anywhere on Earth, because our technology is completely geography agnostic. And so we could produce this not just like far from that one little region, but we could also just make it really far inland. We can be nowhere near a lake, nowhere near the ocean. It doesn't matter. This can really free up seafood production to make it something that can happen absolutely anywhere, getting fresh, tasty, healthy fish to everyone. And we can also dive really deep on making sure that it's as nutritious as people want. We can not just, you know, forgo mercury and plastic, you know, but also we can like be very detailed in terms of editing the nutritional profile. Do you want more omega-3 in the fish that you're eating? Do you want more omega-6? Do you want higher protein, lower protein? These are things that we can have an extreme degree of control over because we're working with this meat on the cellular level rather than on the level of an entire animal. And so I'll keep my talk brief today because I love the Q&A section of these things. But basically what we want to do is we want to take an industry that we feel is inefficient, is crueler than it needs to be, is less sanitary than it needs to be, and is less efficient than it needs to be, and move it towards something that's more in line with our values, more in line with our morals, more in line with environmental sustainability, cleaner, safer, more reproducible, something that just makes a more just and equitable food system for everybody. And so actually this is the first time I'm showing this picture publicly. I kind of got tired of being cooped up. But this is the bluefin that we're making. We've been focusing on bluefin for the past few years. We'll be bringing that to market actually fairly soon. You're seeing one of the earlier prototypes, but you're seeing it here first. So, you know, going from the first like unstructured carp cakes that we made back in 2017 to what we're working now, which is like creating real bluefin maki for sushi applications. I think we've come a long way, and I'm really excited to finally bring this to people in the near-term future. So yeah, I'm Michael Selden, CEO and co-founder of Finless Foods. Really excited to be here and hear from the other panelists.
Thank you so much. That was fantastic. Wow, you blew my mind. Yeah, it's really cool. All right, let's see if we have some questions from the audience, maybe. Feel free to put it in the Q&A. Then we also have, I believe, one poll popping up to check how you feel about this conversation here. Let's see, do we have some questions? Right, I got a question from Ruben Barkington. How do you get the texture to be more fish-like? And is that something that's maybe important for you, or rather not for the specific applications you're looking at?
Yeah, believe it or not, it is very important for us to make something that is very fish-like. Yeah, there's a lot of different things that we have to do. I mean, so we have tissue engineers on staff, and basically we're building off of what's been done in the 3D organ printing industry. So I don't know how much detail people are interested in, but like Meat is not 100% animal cells. You do have like collagen, you have like a structure going on that the cells are sitting on. So you have to find a way to produce a structure that the cells are interested in attaching to and then differentiating into muscle fibers on. That, you know, structure can't just be something that the cells like, it also has to be something that really conveys the texture of what people are eating. And this sort of dives into like material science, like assessing what are people expecting as an experience when they eat fish, like what kind of bite, what kind of snap. Like there's so many different material tests that you can do. You know, there's tear, there's crush, there's like all these things, and they're all quantified and quantifiable. So first you have to study what currently exists today, and then you have to study how can we make that happen from a tissue engineering perspective. So yeah, big focus for us, and it's a complicated problem. Yeah,
for sure. That's fantastic. It's also another great opportunity for engineers to interact with biologists here, tissue engineering, right? Okay, amazing. I think the other questions we can probably address maybe in the breakout rooms later on, or if we have time left. I think we should move ahead with the next speaker. Thank you so much, Michael. This was amazing. All right, so our next speaker, I believe, is Michelle. So let me pull up your bio as well. Michelle works at Lemon, and let me see. All right, here we go. Yeah, so Michelle earned her PhD in molecular and cellular biology from the University of Washington in Seattle, and she was investigating how yeast cells modulate protein modification mechanisms to protect themselves from stress. And then she joined Lemon in 2014 and has held a scientist, project management, and team management roles, developing novel and improved microbial products for a variety of applications, including food, human health, and biofuels. So Michelle, please share your screen, and we're excited to see your presentation.
Okay. All right, hopefully you can see the screen. So thanks very much for the opportunity to talk to you guys today. As Kenza said in her introduction, I work for a company named Lemon, and first a little bit about who we are. So the company has been around for a while. It was founded in Montreal by Fred Lemon at the end of the 19th century, and yeast production started in 1923 and continues today. It has always been family owned, and it was it's been owned by the Chagnon family since 1952. And today there are over 4,000 employees in locations all over the world. We have 45 plants, including 21 yeast and 8 bacteria production plants. And we have, in addition to those production plants, we have offices, distribution centers, and most relevant to me, we have research labs all over the world. And we today are a leader in the development, production, and marketing of yeast and bacteria and specialty ingredients for a wide variety of applications. So sampling of those is shown here on this slide. We have microbial products for animal nutrition, for baking. We still make baker's yeast and a number of other products as well. For biofuels, distilled spirits, savory and flavor applications, and a whole range of others. And for our corporate R&D group, which I'm a part of, our projects aim to push our microbes from our very large culture collection further at some of the things that they already do, and also in some cases to give them new functions. And typically our new product development projects will follow this a cycle that looks like the one that's shown on this slide. So first, it's important to identify that commercial opportunity, and then make yourself familiar with the regulatory pathways and regulatory considerations that will be applicable to that product concept. And then it's time to get started in the lab. So choosing a good starting strain we see as one of the most critical decisions that you can make for a project. Those lab strains that lend themselves so well to classical yeast genetics in so many academic labs are, they're so valuable in some ways, but they may not be the best starting point for certain industrial applications. There may be industrial strains that are much better suited to surviving and performing well under very stressful industrial conditions. So it's important to consider what host organism you're going to choose as your starting point. And then next, of course, you want to design your engineering or selection strategy and get going on building that concept. So build a lot of prototype strains. And once you have some sets or libraries of populations and isolates, you want to screen very rigorously. And your screening ideally should really advance toward more and more relevance in terms of getting very close to application testing, where you're mimicking those the environment that your strains will encounter ultimately in the field. And then a really important next step is to in addition to doing all of those application tests, you want to make sure that you can scale up production, because if you're going to have a very successful product, you're going to have to make a lot of it. And you want to make sure that your microbe can actually go through that process. And a lot of times that process looks quite different than the end application for your product. So your strain has to be able to do both. And then we want to start trialing and transfer your product concept into the field. And so we follow this this product development cycle with all of our new products. And I would say that our successes so far have, they've leaned on each of these steps and categories, but really choosing the good starting strain, and then doing the most relevant lab scale testing that we possibly can, which comes from scaling down the applications test to the lab, and also relying on the expertise of our business units to bridge that gap between the lab and the field. Those have been our key areas for success so far. And I want to say that for me as a molecular biologist, working within a company that can do everything in this cycle, including the scale up and the production, is very exciting, because then it's, you know that the things that you're working on in the lab have a good chance of actually making it into the field. So just to touch on a few commercial examples of what has come out of a development cycle, like I just showed on the previous slide. The first three strains are biofuel strains. So I know this conference is for food and sustainability, but I thought these were great examples of sustainability, at least. So the Transferm family of products, RB3 is a recent iteration coming from that family, as well as FiberFirm and Sucramax are all improved and engineered yeast strains that have higher bioethanol production yield over their wild type counterparts. And each of these is suited for a different feedstock, but they all have in common that they started from good, robust starting strains, and we were very careful in performing the right tests for them. And these are a good example of navigating what were at the time new regulatory pathways for us with a lot of persistence. So at the time that we were launching some of these strains, nobody else had really put bioengineered strains into the field for biofuels, and we led the way on that and just figured out what was necessary in terms of regulatory. Moving on, so Sour Vissier is a newer product and very exciting. It's for the brewing industry. So this is an engineered ale strain that is able to produce lactic acid. So it really simplifies the production process for sour beer, which is very popular right now. So for the brewer, rather than having to do a bacterial and then a yeast, and that may be needing an additional boil step and so forth, they can just pitch this one strain, which for them is a huge time savings, energy savings, cost savings, and it really improves their batch-to-batch consistency, and then they don't have as much concern about cross-contamination issues with the bacteria that they previously were using in the rest of their brewery. So the Sourvisier has solved a lot of challenges for brewers, and this is a very exciting new product from the brewing business unit. And finally, I wanted to touch on Fermade and Glutastar. So Fermade, some examples of the Fermade product line, and Glutastar and some related products are each enhanced yeast strains that were selected through classical strain improvement approaches. The Fermade ones are geared toward the baking industry, and Glutastar and related products are for the wine industry. These are inactivated yeast strains that have high levels of glutathione, which is an antioxidant that in baking helps with dough development, and in wine is important for preservation of flavors and other compounds. So for baking, this is helpful because it eliminates the need for addition of external or of other more pure chemical additions. And for wine, it avoids wine spoilage and really helps with preservation of everything that the winemaker works so hard to get into their wine. And to me, the Fermade and Glutastar are exciting examples of what you can get from enhanced yeast and using yeast as a new way to deliver compounds that improve the function or flavor of food, particularly where yeast is already an ingredient anyway. So finally, I just wanted to put a little plug in here because there are a lot of science enthusiasts in the audience. We hope to hear from you. So if you're interested in careers with Lallemand, you can check out our careers page, and anybody who any undergrads who are looking for internship opportunities, we have an internship page, and at least in Canada, we have a number of internship postings at various universities, and you're also welcome to contact us by email. And in general, anybody who's interested in getting in touch with questions, comments, brilliant new ideas, we'd love to hear from you. So that's all I have, and I can answer any questions if there are any. Thanks.
Thank you so much, Michelle. This was fantastic. And we have lots of questions coming in. So I'm also inviting the panelists to answer the questions. If you go to the Q&A button, you can actually type answers, because maybe we don't have the time to answer all of your questions. But the audience is great. It seems like there's a lot of people with technical background, so that's really fun. And I believe someone raised their hand. I will try and find this person. Right, we have 2 raised hands even. So I will allow one of these people to speak up. I think I also received a question from them, so if I can figure that out. You can unmute yourself. I believe your name is Titi Gosh. Do you want to ask your question?
Sorry, Kenza, we're inviting everybody to put their questions in the Q&As. We're not unmuting attendees.
All right, no worries. So in that case, I'll ask another question. Here's a funny one. So Brian Baxter is asking, how has the beer community responded to SAR-VCA? Are people actually accepting of bioengineered beer, or is that even how it's marketed, or does it need to be marketed like that?
Yes, great question. So first, there has been a lot of enthusiasm from the brewing community. I should note that this SAR-VCA is being sold in the US right now because there was a clear regulatory path and also an absence of certain regulatory barriers that exist elsewhere in the world. But I can say from the trials, that the initial trialing, as well as all breweries that are using the strains now, there's been a lot of excitement about it, basically because of how much easier the process becomes for the brewers. I think I lost the last question there.
Are people accepting of bioengineered beer, or does the beer need to be marketed as bioengineered since there's a modified yeast strain used, or is that not even a necessity?
Oh, good question. Well, in the U.S. there is coming soon. There are regulatory requirements for bioengineered foods, and I'm actually unsure if the beer would fall into that category or not. But if somebody wanted to email me particular questions, I can try to get answers for you. I currently, I believe that, well, I know from our side, we've gone through the GRAS, generally recognized as safe regulatory process through the FDA. And so the information about our strain and how we arrived at that conclusion of GRAS is available. Yeah, but please,
right, thank you so much.
Yeah, there are other people who could answer regulatory questions a bit better than I can. So yeah, particular questions, please just let me know and I'll try to get you an answer.
Great, thank you so much, Michelle. All right, then we'll move on to our last speaker, and after that we'll do a Q&A, and hopefully we can answer a lot more of your questions here. So our next speaker is Ahmed Khan. He is the founder and editor of Cell Agri. This is a news and insights startup exploring the future of food with cellular agriculture. Cell Agri provides the latest updates and insights on a range of topics relating to cellular agriculture. So if you haven't visited yet, definitely go check out the website. And you can subscribe to their newsletter as well. He's also the author of the first cellular agriculture ebook, An Introduction to Cellular Agriculture. Ahmed is a co-founder and member of the board of directors of Cellular Agriculture Canada, a nonprofit organization advancing and promoting cellular agriculture industry in Canada. And Ahmed has previously spoken about cellular agriculture all across the world, so he's really an expert in this topic. So I'm excited to hear from you, Ahmed. You can share your screen.
Yeah, thanks for that wonderful introduction, Kenza. Let me see if my screen works. Can you see my screen?
Yes.
Hey, wonderful. So, hi everyone, my name is Ahmed Khan, and I'm the founder and editor of Cell Agri. Before we move on to the panel session, I just want to give a bit of an overview of cellular agriculture and how it can help us build a sustainable food system, as well as highlight the growth of the industry globally, with a specific focus on the Canadian landscape. But before diving in, I wanted to share some information about how I first got involved in the field of cell agriculture and share some information about Cell Agri. So I actually first learned about cell agriculture for the first time down the road from Concordia at McGill University. I was at the end of my time there, and I was blown away by the concept and the field. Following school, I sought to find out as much as I possibly could about the field, like the latest news, the latest updates, company listings, and even opportunities to join the field. But I was having a problem at the time. There was no one-stop website or tool that had all the information that I was looking for. It was even hard to find out what the latest news was going on at the time in 2017. And that's how Cell Agri began, to be the news and market insights platform focusing on the future of food with cell agriculture. We track and promote all the different players in the industry, as well as share all our insights with our subscribers through our regular newsletter. As Kenza mentioned, Cell Agri has also published the first Introduction to Cell Agriculture ebook last year and updated as well this year. The ebook is an in-depth overview of the field from what it is, why it matters, all the way to common misconceptions and obstacles ahead for the field. We also list out different companies and players in the field at the back of the ebook. If you're interested in a free copy of the ebook, you can visit the Cell Agri website at the end of this webinar to download a free copy of it. I don't want to take too long after Mike and Michelle's presentations, but I want to touch on the benefits of cell agriculture and how we can build a food system for everyone that's better with it. Cell agriculture is the field of producing animal products like meat, dairy, and leather directly from cell cultures instead of raising animals to produce the same products. And compared to conventional animal agriculture, cell agriculture provides a more sustainable and environmentally friendly way to produce the same products to meet the growing demand for animal products like meat, excuse the pun. Now, besides the incredible fact that it is possible to produce these food products from cells, cell agriculture is frankly going to be critical in developing a sustainable food system for our future. Our current food system has produced enough to meet current food demands, but it will not be able to keep up with future demands, especially with a growing world population. It is predicted the global population will be somewhere between 9 billion and 11 billion people by the year 2050. And the global demand for meat is predicted to skyrocket from 60 billion animals to 100 billion animals by 2050, nearly doubling the next 30 years. So this field's going to be absolutely critical for that. And I want to break up the benefits of cell agriculture into 3 categories. We have environmental benefits, impact for human health, and animal welfare. But in light of iGEM Concordia's work, I want to highlight the food security aspects of cell agriculture. COVID-19 and the pandemic has really highlighted the need for resilience in our food supply chains to ensure that everyone does not lack access and availability to their food needs. And cell agriculture really can help address that by being a way to locally produce food anywhere and everywhere on Earth and even in outer space. Food security has not really been a conversation topic in the US and Canada until the pandemic, but food security is a major reason why there's an explosion of interest for cell agriculture in Asia, particularly in Singapore, Japan, and across the Middle East. Without requiring as many resources, countries that usually rely heavily on food imports can now produce enough food for their populations locally. So when I first began Cell Agri and began tracking the field a few years ago, you could literally count the number of players in the field on your fingers in your hand. It was a handful of companies that seemed to be mostly based around the San Francisco Bay Area in California. And now today, the field has exploded globally and there are players all over the world working on the future of food with cell agriculture. And I personally think it's incredible that scientists and entrepreneurs all over are taking the initiative to build our future food system in their own countries and adding their own unique angle to it. Pictures shown here are from media showcases from different companies around the world. And no 2 pictures here are from companies working on the same product in the same company. From Finnish Food's first showcase of their cell-based seafood, to Memphis Meat's cell-based meatball, all the way to the first cell-based steak by Olive Farms, companies around the world are doing fantastic work in building our future food system. I also do want to highlight 2 players in Asia, Shiok Meat and their cell-based shrimp dumpling, and Hong Kong-based Avant Meats and their bite-sized cell-based fish maw. It highlights how cell agriculture can help develop a wide range of products to feed our future populations. So with the global growth of the field, what's happening exactly here in Canada with cell agriculture? Well, Canadians have played a big role in helping get the whole cell agriculture field to where it is today, but there's definitely a lot more to be done to make Canada a key hub for the field in the future. As the field grows, it's going to be important to develop a complete cell agriculture ecosystem to make Canada a leader in this future food field. And from coast to coast, from Vancouver to Calgary to Ottawa and even Toronto and even PEI, there's a lot of research done in Canada to help scale and grow the field. And if there was more support from government agencies or even public-private partnerships, this research could be translated to forming new startups or helping established traditional agriculture and pharmaceutical companies partner and support new emerging startups in the field. And the momentum has been moving forward in Canada. We're starting to see a few more Canadian startups that arrive on the world stage. And in the future, we'll see more startups come out of stealth mode or come to be founded in the country. I do want to highlight a company, an Edmonton-based company, Future Fields, and their work in addressing a key part of the cell agriculture field's value chain, making an affordable cell culture media formulation to help cells grow. A few weeks ago, the start of August, Future Fields announced that they are the first Canadian cell agriculture company to be accepted into the Y Combinator program, a leading accelerator for innovative startups. And that's a great sign for the field moving forward in Canada. It looks like I'm a bit out of time here, but I just want to highlight this picture of outer space. Through a global collaboration of companies in the cell agriculture ecosystem, including Finless Foods, the field has shown that even outer space isn't a limit for cell agriculture. The field, if we build it correctly, can become our future food system to help us sustainably produce food and even go beyond that for future applications. I do want to add before closing that I first learned about cell agriculture when I was back in Montreal, and I wanted to get involved in it right away. If you have the same interest, I highly encourage you to do the same. The field is still in its early stages in Canada, and there are lots of ways to help support and grow the ecosystem there. So I want to thank you all for your time and listening to my brief exploration. I'm looking forward to the panel and hearing all your questions.
Thank you so much, Ahmed. All right, let's see if we have some questions popping in. There will also be a poll about your talk. All right, let's see. What's the audience? Right, it's not that I have a question prepared for you. So, one of Canada's largest industries is obviously agriculture, and over newer fields such as synthetic biology, it seems like Canada is always a little bit having the desire to walk in the footsteps of our southern neighbors, I would say. So do you think that here with cellular agriculture, we have a really great opportunity? I believe you already mentioned it in your talk a little bit, right? That we can really shine, and this could be our moment to be one of the world's leaders. I mean, we've seen some enormous investments recently as well on Perfect Day from the Canadian Pension Fund with like $300 million into this. So maybe the fact that Canada has this strong affinity for agriculture, cellular agriculture then becomes something that the country is more interested in investing in, or what do you believe could help us become a world leader in this?
Yeah, that's a really great question. So you're totally right there that Canada is a global agricultural leader. And when you want to be forward facing and seeing where the future of food is going to lie, to remain a relevant key leader in agriculture, Canada should be offering more support and helping grow and promote a whole ecosystem around cell agriculture in the country. If you look at globally how cell agriculture startups have formed around the world, typically it's more like outside of government-funded research at universities, spin-offs of companies form and they grow from there. Canada has an incredible research environment all over the country, and especially in Montreal too. So if there's more government support for funding for this field, we can likely see more scientists and founders emerging to help make Canada a key player in this field. And as there's more awareness of the field growing in the country, we'll likely see more private-public partnerships, more investor interest, and eventually we can become a global leader.
Yeah, I'm crossing my fingers for it. All right, thank you so much, Ahmed. I don't believe there's a second question for you. I'm trying to find it in the pool. If not, now we'll transition over to our panel discussion. Maybe we'll just start off with answering some questions from the attendees. This can be for any of the speakers. I have some questions prepared for you all, but since we have so many questions popping in the chat, I feel like maybe it's more fun to answer some of the audience questions right now. So please, any one of the participants, feel free to put your questions in the Q&A. In the meantime, I'll pull up a slide that explains the breakout rooms a little bit if you want to stay on. So let's see, we have a question here, I believe it's from Michelle. Is there any difference between, this question is from Aliyah Naz. Is there any difference between nutrients of the two, like natural and synthetic, when you're making flavor compounds or specific food compounds?
So I might repeat the question back to you, Kenza, so I understand well. The question was, is there a difference if a particular compound that the microbe makes is originally natural or synthetic?
The question is more about whether there's a difference in the nutrients that compound brings. Is it an exact copy of the natural nutrient or of the natural product, or can there be differences in nutritional value? I believe that's what this person is asking.
Okay. I think in this case, I think it's probably hard to give a very specific answer. It would really depend on for, I suppose, the natural form, where that nutrition comes from. If it really is derived from a single specific compound, then in that case, it could be very, very easy to replace with a synthetic version that was made with some other production organism, for example. So it really would depend on some deeper knowledge of where the nutritional or other benefits might be coming from. So yeah, it's a very generic answer because it'll really depend.
Yeah, Michael, I believe this is also something you brought up in your slides, that you might be able to add certain nutritional values to your fish, like vitamins, etc. Do you think maybe people are wary about that, or it seems like there is always a comparison between what's synthetic and what's natural, especially if it comes to these nutritional compounds. Could you comment on that?
Yeah, for sure. You know, it's sort of an interesting thing because it's like what's natural. I know people think that I'm like sort of being annoying by answering it that way, but I think it's sort of a genuine reflection. I mean, like, what's natural in fish today? Well, having high levels of mercury in plastic is what's natural right now. So if people want that, there's a source for that. But I think that we can provide something that's a little bit better than what's going on out there. It's also natural for, you know, fish to not be very fresh if you don't have like the luxury of living close to a body of water. We can change that. I don't know. I mean, this is an iGym conversation, so I can give the whole thing of like, oh, our phone's natural, our plane's natural, but I feel like everyone's on board with that already. Yeah. We work really hard to like assess all the different nutritional components of what we're doing. We see it as really key to this because more than, I mean, the company is really founded on, you know, environmental principles. And like, you know, if you come at this from the angle of trying to just like make the most money the most quickly and put people at risk, or, you know, don't get things nutritionally where they need to be, excuse my WhatsApp, you're going to create like a negative perception for the entire industry. And so it's really important that we take a lot of care to make sure that this is as good nutritionally and as good for the environment as it possibly can be right off the bat. Because like Ahmed said, like, we're not the only ones in this. Like, there's tons of people, and we have the unfortunate ability to ruin it for everyone if we're not careful.
Yeah, that's a really good point. Michelle, do you feel that way as well, as being like a more, I mean, a really large company here in Canada? Do you feel like you're setting standards as well for the rest of the field?
Ooh, I think we would. I guess we'd like to think so in setting standards. Yeah, I would say that, well, more to answer that specific question, it's a bit of a tangent from what Michael was just saying, but there are some examples of our improved strains indeed setting a new standard. Those biofuel strains led the way in what was possible. I think a lot of the initial feedback to the R&D teams who were trying to improve strains for better yield in bioethanol was that, oh, nobody would accept an engineered strain. It's not like, it's just not done, or it'd be unfamiliar, or people would be scared of it. So the team basically took a look at what regulatory steps were necessary to prove the safety and get on to the relevant approved regulatory lists and so forth. And we went through those processes, at least showed ourselves that it could be done. And basically what was ultimately what made those new products a success was showing the customers what those strains could do, and what the strain improvement that we had brought to those new products, what that translated to them in terms of making their process more efficient, and ultimately either saving them money, making them money, and probably both in the end. So that's maybe a little bit of a different, I may have taken your question in a different direction, but
yeah, great. Okay, so maybe now we can talk a bit more about the sustainability of cellular agriculture. It seems like a lot of companies in this field are trying to obviously solve problems related to sustainability, like Michael, you were saying food, right? But one of the things that comes to mind is also the supply or the manufacturing of those meats itself, or of whatever you're growing, right? And there's one question in the audience here asking about how long does it take for you to grow, let's say 500 grams of fish. And maybe Ahmet, we can extend this question to you if you notice about other companies maybe in the field. Like how long does it take comparatively? Maybe we can speak in protein numbers or something, to grow the same amount of meat synthetically versus in the wild. And maybe you can comment on resources as well.
Yeah, so I will give an answer to that, I promise. I will just start by saying, though, it is a very difficult question to answer, not because the process is super complicated or anything, but because there's a lot of factors that really do matter. Depending on like how big of a facility you have, you're going to be producing a vastly different amount of this stuff. Cells, when they divide, animal cells divide every like 24 to 72 hours. So what that means is every 24 to 72 hours, you have double of whatever you just had. So if you have a 2-liter vessel, you know, that means that your growth curve is going to do like this, basically. So it's going to take a very little amount of time, but you're not going to have much stuff. If you have double the vessel size, though, that means in another 24 hours, you have double that. So basically, the bigger the vessel, the more of this stuff you're able to produce in a short amount of time, because it's an exponential growth. So that means that it really does matter how big your factory is. So let's pretend that we're doing this on the scale that pharma produces animal cells today. So that maxes out at around a 15,000 to 25,000 liter bioreactor. Let's pretend 15,000 because they're more standard. Basically what you're looking at is if you are seeding your bioreactors at a standard density of 0.5 gram dry weight of cells per liter of capacity, which is normal in pharma today, and you're growing it up to 20 grams a liter, which is around where pharma maxes out. There's a reason why they stop there, and it's not a theoretical limit. But basically, we can go much further. But let's say that all we do is go up to where pharma's at. That means that it takes about a week to get from 0.5 grams of dry weight per liter to 20 grams of dry weight per liter. And then from there, you have this raw cell mass, which has like the right flavor of what you're looking for, but it doesn't have the texture. So then you need to move towards a differentiation procedure, which will get the cells to form muscle fibers. That's super dependent on the species, and Ahmed might know a lot more about that than I do. But you know, that can take anywhere from like 2 to 3 days to like 2 to 3 months. For us at Finless, like we're estimating our final process will be about 3 weeks. So basically what that means is in about 1 month, so you know, 1 week of growth, 3 weeks of differentiation, you can end up with just tons and tons and tons of fish meat. And if you run that over and over again, that was basically the slide that I ran during my presentation, which is that if you have two 15,000 liter bioreactors and you run them for 2 years, which is the amount of time it takes for the most efficient fish farming to produce fish, That is about double what one 50-meter in diameter aquaculture net can produce. So basically we're doubling the efficiency in the same amount of time. But what I want to point out is we're producing bluefin tuna, which cannot be farmed. And so in terms of environment, people ask about like sustainability of it. And I'm like, well, it's like an endangered species. So kind of no matter what we do, it's actually better. But basically we're producing about double the amount of bluefin tuna than, you know, they're producing salmon, which is like the best numbers they can possibly get. I know it's a lot of stuff to throw out there all at once, but I don't know, it's iGEM. People want details.
That's fantastic. Yeah, that's a huge amount of fish you're saving there. How much, actually, let's go, so from bluefin tuna, I actually did a little bit of research lately on that specific topic because I went to eat sushi and I usually don't eat tuna, and this time I made an exception, but I regretted it afterwards. And so I was like on Wikipedia actually during dinner, trying to look up facts. There are different species of bluefin tuna. Could you maybe give some details into like which species are like most endangered and which one you're most likely to find either canned in the supermarket or in sushi?
That's a great question, and it's not one that I ever get. Basically, yeah, there's currently classified 3 species of bluefin tuna. There's Atlantic, Pacific, and Southern, all 3 named after like where they are. There's a debate within the bluefin tuna community about whether or not they are actually separate species. They taste the same, basically, and when they taste different, it might be because of like their diet. You know, let's be scientists and like think about like what is a species? Like what defines the difference between species? Species are animals that are sexually compatible with each other and can produce viable offspring. How would you test if a Pacific bluefin tuna can produce viable offspring with an Atlantic bluefin tuna? They're nowhere near each other. We don't know how to farm them. So basically what I'm trying to say is they actually could be the same species. We don't know how to make them breed and they're geographically not next to each other. So we've just decided they're separate basically. But a lot of bluefin tuna experts, not in my company, like separately from us, are like, yeah, they're probably the same thing. And if you want to get specific, I mean like Pacific is the one that's been on and off the endangered species list. Southern is pretty okay, and Atlantic has been pretty decent. For the past 2 years, because of the successes in the NGO space and the regulatory space, there actually has been a really great uptick in the population of all 3. For the past 2 years, it's actually been great bluefin tuna population recovery, which we think is fantastic news. Hopefully it stays that way, knock on wood.
Nice. All right. So I'm going to ask a really quick question, and the answer is just a number to all 3 of you. How many cellular agriculture products do you think will pop up on the Canadian market in the next 5 years?
I'm literally guessing 50. I mean, what counts? Like, is it impossible for a cellular agriculture product? Like, you know, people who genetically engineer yeast for beer. Like, is that like cellular agriculture? Because that's like already kind of viable. Like, these things are already happening. Is cellular like when we produce rennet for cheese? Is that cellular agriculture? When we produce insulin, like, is that cellular agriculture? So it's like, I don't know, a lot.
Let's say products that the consumer is aware of it, that it's engineered genetically. Very aware.
That's a really great question, and it's hard to give a specific answer on that, just because Michael will agree with this. Instead of getting to market fast and getting these products there, it's more important to get the products to market correctly in all the proper mechanisms to make sure food safety is established, as well as the public understands the full picture of what this product is, how it works, most importantly, why are companies and players all around the world looking to make food directly from cells. That there's a full big picture there that has to be addressed. While working with food regulators as well, there has to be clear communications from both sides about how the products are made, what are the safety standard concerns, and how can we make sure they both meet each other. So if that does happen, we can probably see a lot more products coming to market soon, not just in the US and around the world, but also in Canada, once this bigger picture is established.
Yeah, and Kenza, I would add, well, I don't have a number to add, but I hope it's more and more. I would say just on the topic of like how many engineered or like cellular agriculture based products will the consumers be aware of? I hope that increases quite a lot, because I think in general, like transparency is good, and also just showing consumers what they get when with new processes, and also with strain improvements through engineering or other methods. Like I think just showing the range of what is possible is really important. And I think that there are some companies so far that are, I think it's really exciting to see ones that are so upfront, even like incorporating it into their marketing, that like we're using something, an ingredient that's clearly engineered, and this is what it does, and just being like kind of, yeah, just showcasing what the new developments can bring. Like I hope that's a change that happens, because that would in turn lead consumers to I would hope like ask more questions about what they're getting with improvements, and really start to understand what yeah, the new value the different improvements can bring. And one thing, thinking about the Sauervisier, one thing I did think to add into my chat answer, but I didn't mention before, is that from Lallemans's perspective, we wanted to go the route with that strain of being very open to our customers, and so it says right on the Lallemand site, it's an engineered strain. There's a little bit of detail of exactly what we did there, but we wanted to make sure that our customers knew exactly what we had brought with that new strain, and what they were getting. So yeah, I think just transparency, especially as much as it showcases what you can get, is a good thing.
Thank you so much, all three of you. And I'm hoping that the participants will want to unpack this terminology question as well during the Q&A, because what is synthetic, what's natural, what is cellular agriculture, and what is synthetic biology, and what is engineered and what's not. It's a good point that Michael brought up in the chat as well. I will just, we're really are over time now. I will quickly give the word to D3, I believe, who want to give a little word, and then please move into the breakout room. Breakout room number 1 is where you can find D3, and you can join their session, and they will have a little workshop on vision and mission when you're working in a group project, or this could even be a startup. The second room will have Ahmed, and you can ask him any question about the cellular agriculture field there, and we can have a nice discussion. The third group will be the iGEM teams, and in general, you can get more info about synthetic biology there. If, I'm not sure, Michelle, do you also want to stay, and Michael, for a breakout room? If so, we can make a 4th one. And then the participants, please change your name to the number of the breakout room you want to go in. Then it will be very easy for me to put you in those rooms later on.
I'm happy to stay if that's helpful.
All right, so we'll make a 4th room. Michael, if you do have time, you can join the 4th room. I'll put you in there. The link is in the chat. Please stay on here, as D3 still has something to say, and change the number in front of your name in the new Zoom, okay, to the breakout room you want to be in. I'll repeat these instructions in the new Zoom chat as well. So please open up that new Zoom. First, we'll have an intro by District 3. Take it away, Anna.
Thank you so much, Kenza. I need, okay, now. They're sharing screen, so I need to, okay. Let me do this. So can everyone see my screen?
Yep.
All right, so well, thank you so much, Kenza and the other organizers for having us here. I am Ana Fernandez, and I'm coordinator of life science initiatives at District 3. District 3 is an innovation hub based at Concordia University. For those of you that haven't heard from us, we support technology-based teams to create businesses and startups with global impact. And I must say, I was really loving the conversations you were having, especially those related to how can we make sure that innovation in cellular agriculture or in synthetic biology actually gets applied and reach the dinner tables of Canadians and the world. And that's a problem that we are trying to solve too at District 3, helping entrepreneurs and life scientists actually make that possible and providing them the space and the business support and the knowledge, the network that they would need to make that possible. So I think it's actually quite relevant that you were talking about that at the end. And I'm just going to be telling you a bit about District 3, how to reach us, how to get in touch with us, for you also to understand better why we're here talking to you. So we've been around for about 6 years. As I mentioned, we're based at Concordia. And until now, we have worked with about 600 startups, helping them reach the market. Of those startups, we usually work with 100, 120 every year. And 30% of those entrepreneurs are working in life sciences. So we do work a lot with scientists, masters, PhDs, postdocs. We have even also some undergrad scientists that have a research technology that they want to find an application in the market. They can come to us and we'll help that make it possible. You might be familiar with these guys, Kevin, Shen from Synbio. They actually were born at Concordia and they passed through District 3. They are using synthetic biology and producing cannabinoids based on yeast. So we are very happy to be supporting them, and we would like to support other teams or members such as them that want to see their research reach the market. Actually, one of the newest programs that we have developed is for early stage scientific entrepreneurs that have a research that is well-grounded and they want to find their market fit. We will help you over 8 weeks to put you in touch with our networks in industry, different industries such as food, agriculture, but as well as therapeutics, depending on what you're doing, and help you find that research market fit to then validate your business model and hopefully become a successful company. So you can find some of that information here at district3.co. You would also be able to learn more about District 3 and our programs. The other thing I wanted to mention that it's very important, it's really crucial to make sure that the research get out of the labs and into the market is having a space for conducting experiments. And we're very excited that with the help of Concordia University and provincial and federal governments, we recently did an investment of 52 million in the first biotech accelerator that has laboratory and co-working space in Montreal, based at Loyola campus of Concordia University. We also have subsidized access for genome fundraise, so very relevant for those teams that are working on synthetic biology. We will be able to host teams there and help them reach their goals. What I have to mention as well, that it's very important for you to know, is that we operate as a non-for-profit, so District 3 takes no equity or intellectual property of any of the work that you would bring to the lab. Given that we're funded by Concordia as well as the government, that's kind of how our business model works. So it's very good for scientists that really need this laboratory space that want to join and work with us. And I know we're a lot of time, so this is just the last thing I want to say. We actually do very similar events as the one from today. We're gonna have one in September 22nd. We're gonna be talking with the people from FredSense. They actually started their business as an iGEM competition. There were 6 of them. That was back in 2014. Now they are still 2 of the original iGEM members, Emily and David. And they will be talking about their technology to detect water contamination. So they will be also talking through their journey to iGEM and how they managed to start as a team of 6, 7 people when they were competing iGEM, and how with the help of other incubators and the government, they were able to make that iGEM project an actual startup and a successful company. So if you're interested, I think that would be very relevant for you. You can join us. How can you join us? So at the Eventbrite of District 3, or if you follow us on Facebook, LinkedIn, you will see the event there. And yes, it will have a very similar format as the one today. So everyone will also be able to ask questions and participate in the panel. So that's pretty much all I have to say. Thank you so much again for giving us the chance to talk. And here is my email address, ana.fernandez@district3.co. If you have any ideas, you want to talk about entrepreneurship, you want to talk about science, feel free to reach out. We're very open, and I'll be happy to have a chat with you. Thanks.
Thanks so much, Anna. All right, so that's it for this webinar. I just want to thank some of our sponsors of iGEM, and then I'll give the word back to Anna, who from Workspace, who will close this off. So the funding, for this webinar came from the Sustainable Action Fund from Concordia, that's supporting the iGEM team, and a very big thanks to Workspace. Anna, do you still want to say something? Anna from Workspace.
Yep. Thanks. Thanks very much, Kenza. Just a few quick words on behalf of all of us at ForceSpace. I'd like to thank you all for being here, sharing your expertise, participating in the discussion. Obviously, you had tons of questions, so I hope people do follow you into the breakout rooms to continue the conversation. A special thanks to the iGEM organizing committee. iGEM is currently doing a virtual residency at ForceSpace, and this event is a part of that, so thanks so much for being with us. The recording of today's presentation of this event will be available on our website, which is concordia.ca/4. And of course, it's already on Facebook now. So for those of you on social media, do follow us at CU4Space to keep up with the multitude of workshops, conversations, and these kinds of events that we're constantly producing. It's been a pleasure. See you all in the breakout space. The link is in the chat. Thanks, everyone. Bye.